Let's talk about compositions of function. If you want to pause this and read the objectives, please do. Now let's move on. Composition of a function. We have this definition, and again, whenever I loaded this into my computer, it left off a few items. So let me fill that in for you as I read the definition off. So what it basically is that we're going to take two functions, right? And so let's talk about it for a second. We got f of x. Is the name of the function's f. It's in respect of x, and it yields out a y outcome. We understand that. But when we're doing a composition function, that means we have two functions. In this case, we got one that's called f and one that's called g. And we're going to plug the function into the other function or vice versa. So this statement here says f of g basically means that everywhere as I see x in my f function, I'm going to plug in the g of x function. If it would have been g of f like this, then that means I would have took my g function and everywhere as I saw x, I would have plugged in the f of x. So that's what that is saying. And this notation is just telling me, or this statement here is telling me whatever I'm plugging in, the function that I'm plugging into the other function will determine the domain. However, we still look at its originals before we put them together, but the bigger factor will be the one that you plug in. So in this case here, since we plug g of x into here, that's the domain we focus at. So let's look at it. Okay, so our example 1 here says we are giving this function f of x is equal to 2x minus 5. And we are also giving a function of g of x is equal to x squared minus 3x plus 8. Now let's look at this. We have a polynomial here, so it's going to be all real numbers. There's no restrictions, so my domain will be all real numbers, negative infinity to infinity. And then we look at our g of x. Well, it's all real numbers too, negative infinity to infinity. So my originals domains are going to be all real numbers for both of them. So if I plug all real numbers into an all real numbers, our domains are going to be all real numbers. And in this case, that's how this one's going to be. They said take f of g of x. So what I'm going to do is I'm going to take my f function, and everywhere I see my x, I'm going to plug in my g of x. And well, let's just do one more step. So let's write it out. 2 times x minus my 5 is my f function. Let's plug in our g function. Our g function is x squared minus 3x plus 8. Next, we're going to distribute this 2 to everything inside here. So 2 times x squared is 2x squared. 2 times negative 3x is a negative 6x. 2 times that positive 8 is a positive 16. So see what I did? We're going to bring down that minus 5. We're going to put together any like terms, and so far the only like terms we have is the constants. So I have 2x squared minus 6x. I have a positive 16 here. It means I have $16 and I spent 5 of it. That leaves me with a positive 11, and that would be my answer. And we can look at it just to make sure. So I wanted to get, yes, I agree. Okay, with their answer. So I want to take a second and let's work it as if it asked you g of x or g of f of x. So let's do that. I'm going to take my g function, and everywhere as I see x, I want to plug in my f function. Remember, our g of x function was x squared minus 3x plus 8. My f of x function is 2x minus 5. So now let's plug it all in. So I got 2x minus 5, 2x minus 5. Now let's go ahead and solve and clean it up. Well, this first parentheses has a square on it, so that means I'm going to have 2 of them. I'm going to multiply it to itself twice. I'm going to distribute this -3 to that +2, which gives me a -6x. I'm going to distribute this -3 to this -5, which gives me a +15. And then I'm going to, oh, no more distributing. We're done. So I'm going to bring down the 8, +8. Now let's clean this up. I got first times first, so I have 2x times 2x plus the outers, 2x times that -5, then my inners. So I got plus -5 times 2x, the +2x, and then my last. So I got -5 times -5, and let's bring the rest. Minus 6x plus 15. Actually, before we do that, let's put the 15 and 8 together. You see this here. It says we have $15, and then we deposited $8 more. We have 23, so it's a +23. Now let's go ahead and put these together. 2x times 2x is 4x squared. +2x times -5 gives me a -10x. -5 times +2x gives me a -10x. A -5 times -5 is a +25. Bring down the -6 plus 6x plus 23. And now any like terms we can put together. Well, I have these here. So this is saying that I'm in the whole $10. I spent $10 more. So that's a -20. Oh, hang on. Let's just do this. Let me change the color just so I can. So I got -10 plus a -10 is a -20 plus a -6. So I got -26. And then I got this +25 and +23. That gives me a +48. So that was just if they asked you to do g of x. Okay. Let's move on. And that's what they asked you to do here. Of course, they got 48. So let's look at that. We had to plug in the 2x minus 5x. And that means that needed this square on there because my f of my 8x squared. So let's just look at this right quick. We got g of x. I want to rework it because I got something different when we did it on the other piece of paper. So it wasn't hard to double check. So now I'm plugging in 2x minus 5 everywhere is an x. All right, plus 8. I have 2 of these parentheses, so this one should have had the square on it. Oh, it doesn't like me writing on it. Okay. So now I have 2x minus 5 times 2x minus 5. And then I'm going to distribute this -3. So -3 times +2 gives me a -6. And don't forget the x on the 2. And then I got -3 times -5, which is -15, plus my 8. Okay. Now let's do this. +2x times +2x is 4x squared. +2x times -5 is -10x. -5x times +2x is -10x. -5 times -5 is a +25 minus 6x. And then I got the negative. Oh, and then let's talk about this. -3 times that -5 should have been a +15. So let's write that. So now I have 15 plus 8 is 23. We're going to put these terms together, which gives me 4x squared minus 26x. And then I have 25 plus 23. Yep. I believe that I got it right. And let's just double check my paper. And yes, it's always good to double check, you know, does not hurt. Make sure you're sure of your answer. Oh, and if we was to state what the real numbers are, what the domain is, it's all real numbers because it's polynomials. However, when we look at this next example, if you'll notice, f of x has a square root, an even root. So then that means that it has a restriction, right? Because an even root cannot yield out a negative answer. So to solve the domain of this one, I'm going to take what's inside the root, set it greater than or equal to 0. Well, it was just x. There was nothing else going on. So we know it's restricted. Its domain is going to be when x is greater than or equal to 0, because it can have 0 in the square root. And then g of x, well, this is all real numbers because it's just a polynomial. So what it's asking you to do here is solve f of g and g of f. So what we want to do is take our f of g of x, and in my f function, I'm going to plug in the x minus 3 because that's my g of x function. I got square root of x minus 3, and that's all I can do. That's as far as that would go. So let's take our g of f. We got our g function, and everywhere as I see my x, I'm going to plug in the square root of x because that's my f function. And now I got square root of x and then minus 3, and that's as far as that one will go down. There's no like terms that we can put together. All right. Let's go to our next one. Our next one says the domain of f of x. Oh, this is where it was talking about the domain of that square root. So let's go back. So on B and A, so let's solve for it. So B, we did A, now B says find out what is the restrictions. Well, if we look at it, we plugged g of f in, or excuse me, in this one here, we plugged in g of x into f of x, right? So we talked about our original, our f function, since it had that square root, we know that it was restricted at when x is greater than or equal to 0, right? So you wouldn't want no negative numbers, or it wouldn't be a real number. So whenever I write this domain, I got 0 to infinity, positive infinity, meaning if you was to draw it on a number line, 0 here and x is greater than, and since it's equal to, I'm going to put a bracket on it. However, when I look at the g of x that I plugged in here, my g of x is all real numbers, right? So our domain for f of x here is going to be this one. We already solved for it. Our g of x, it was all real numbers for that one. So the domain here is all real numbers because it's what we plugged in. Now, when we look at the other one that we solved for, we have to take, because it is set up. My apologies. Let me get this done. My pencil. Let me change this up. So now when we take this one here, we know that we plugged in f of x, and f of x did have a restriction, and that's what we got here. So the domain here will be this. Okay. However, we have to consider the original, and the original was a polynomial, it's all real numbers. Okay, we'll work some more. It can be confusing at first, but once you get the understanding of it, it won't be so bad. So the next slide is just talking about what I just said to you. Okay. Put in some notation. Okay. This we have, it says g of x can is greater than or equal to 0. And then if we say that, then we can take the x minus 3, set it greater than or equal to 0 and solve. And this is what we get. 3 to infinity. You can't put a bracket on infinity, so that's a typo. It has to be a parentheses because you can't stop infinity. This notation here is a set builder notation. It's telling me I have a set that builds on x, where x is greater than or equal to 3. All right. So the domain of G of f consists of the values of x in that f of x. We came out with a domain of 0 to infinity, for which G of x is defined, right? And then they said, okay, so the domain of G of f is going to be, because we have that even root. Remember, you know, we look at what we're plugging in as well as what our end answer is. Okay, so if we have the G of f of x, we're plugging in that square root, right? Oops, that's not 3, it's 3 here. We plug that in. So we have a restriction on the f that we plugged in, and then our outcome gave us a restriction as well, and it ended up being the same restriction. So that's my domain. All right. Decomposing a function as a composition. If you want to read this part, go for it, and let's actually do it. All right. So example 3 says we got a function called h of x, which is equal to 2x minus 3 all to the 5th. And we're going to find f of x and g of x, okay? And this here is basically saying we're going to take h of x, we're going to set it equal to f of g of x, okay? So when we look at it, the h of x raises the 2x minus 3 to the 5th power, correct? So two functions that can be used for the compositions are going to be, and we're going to let f of x be one part, and it's going to be x to the 5th, because, I mean, that's what we got here. The original is raised to the 5th. And then we're going to let g of x be equal to 2x minus 3, which is the inside of that parentheses, okay? So now that I've done that, now I can apply that f of g of x. So let's take let's just write it in this notation. So I'm going to take my f function. Everywhere is a cx. Let's plug in the g of x, which is f of 2x minus 3, right? What is f of x? It's going to be x to the 5th. So now this is what I have, right? And if you think, I mean, that's all it asked you to do. They didn't ask you to simplify it or give you anything else. So, but if you think about it, that makes sense, right? And this is just doing the math work. So this would be your answer.